Good morning, everyone. So, we're going to talk about problem solving and creativity. Problem solving. Anna's food catering business has been profitable as there is no competitor. Lately, a new catering group was put up offering us good services similar to hers. With the presence of the competitor, some clients have shifted to the new provider. Anna inquires on how to sustain her customers' loyalty. This situation illustrates a problem. A problem arises when there is a difference between where you are now and where you want to be. A distinguishing feature of a problem is that there is a goal to be reached through some action on your part, but how to get there is not immediately apparent. There's an obstacle or a gap between where you are now and where you want to be, according to Robertson, year 2015. In Anna's case, her goal is to sustain the customer client, but the solution is not there yet. This is the current state. A necessary element of a problem is the presence of an obstacle or block toward the attainment of the goal. For this reason, problem solving happens when an individual strives to eliminate the obstacle that hinders the attainment of the desired goal. According to Rees, year 1994, if no obstacle hinders progress toward a goal, attaining the goal is no problem. Figure 11. Elements of a problem scenario. Current state. Block or obstacle and desired goal. Problem solving refers to cognitive processing directed at achieving a goal for which the problem solver does not initially know a solution or solution method, according to Mayer, 2013. This definition consists of four major elements, according to Mayer, 1992, and Mayer and Wittrock on 2006, namely, number 1, cognitive. Problem solving occurs when within the problem solver's cognitive system and can only be inferred indirectly from the problem solver's behavior, including biological changes, introspections, and actions during problem solving. Number 2, process. Problem solving involves mental computations in which some operations is applied to a mental representation, sometimes resulting in the creation of a new mental representation. Number 3, directed. Problem solving is aimed at achieving a goal. Number 4, personal. Problem solving depends on the existing knowledge of the problem solver so that what is a problem for one problem solver may not be a problem for someone who already knows a solution method. Next, types of problems. Problems can be classified in many ways. For one, it could either be well-defined or ill-defined problem. According to Robertson, 2015, he described a well-defined problem as one that provides all the information required to solve it. Johnson, 1997, considered it as a problem requiring the application of a definite number of concepts, rules, and principles being studied to a constrained problem solution. The problem tells you everything you need to know to solve it, or whether you need to work out of yourself what you are supposed to do. Likewise, it tells you whether or not there is only one answer or solution, or there are many solutions. For example, in the problem 4 plus 3 is equal to 7, you are certain that you are to add the two numbers and there is only one correct answer. You also know that you are 100% right or wrong. Nevertheless, there are instances that you have everything to know to solve the problem, but you cannot still arrive at the answer. In mathematics, for instance, you know the MDAS, which is multiplication, division, addition, and subtraction rule, but applying them may not be clear to you. An ill-defined problem. An ill-defined problem, meanwhile, is one where the initial state of the problem is given, but what the goal state looks like is not provided, according to Robertson. It is typically situated in an emergent from a specific context where an aspect or aspects of the problem scenario are not well specified, the problem descriptions are not defined, or the information needed to solve it is not expressed in the problem statement, according to Chi and Glaser. Because of this, there may be many correct answers as the learners have divergent circumstances and experiences related to the emergent context. An example of an ill-defined problem is, you notice the population of your town is tremendously increasing and you are alarmed of the consequences. What could you do? This problem is ill-defined as it is a complex problem. The solution to the problem is multi-phased as there is an interplay of social, political, religious, and psychological issues to consider in arriving at solution. The solution is one town varies to another town as their circumstances are different. Thus, there is the possibility of getting many correct responses. Approaches to problem solving. Several approaches have been advanced to explain the problem-solving abilities of individuals. One is the behaviorist approach, reproducing a previous behavior to solve a problem. A person faced with a problem situation is likely to use the same solution previously used and was effective in the past. To prepare the garden before planting, peak method is traditionally used because the crop science teacher told it so. In contrast to the reproductive approach advocated by behaviorists, the gestalist approach to problem solving is a productive process. Kohler's experiment with apes underscored the role of insight in the restructuring of a person's representation of the problem. As the individual ponders upon how to solve a problem, a flash of an idea comes to mind, which eventually provides the best solution to the problem. This situation illustrates the eureka moment, the moment a person realizes or solves something. A science student saw a rural folk using Acapulco extract, locally known as andadas, as an antifungal treatment. The extract was used on his face to treat tinea flava. After 3 days of treatment, the extract did not only treat the main problem, but it also peeled off dead cells in the face. The student concluded that the plant extract also has exfoliating effect. Next, problem-solving cycle. Problem solving is a complex process. It is not a single skill, but rather an overlapping of some thinking skills as logical thinking, lateral thinking, synthesis, analysis, evaluation, sequencing decision, research, and prediction are likely to be involved, according to Thier. Metacognitive thinking, creativity, and transfer of learning interplay in the process. These cognitive and metacognitive skills are expressed in the several models proposed to undertake problem solving. The ideal model by Bransford and Stein is adopted to explain the process of problem solving. So here are the steps to solve a problem. Step 1. Identify the problem and opportunities. Problem solving initially identifies the problem or potential problems. Determining the causes of the problem is necessary to pinpoint the major cause to prioritize in resolving the problem. Considering the problems with a positive outlook serves as opportunities to do something creative. When problems are treated as opportunities, the result is often an unexpected solution or invention. It can be beneficial to actively attempt to identify problems that have gone unnoticed. People who identify important problems opportunities are often among the most successful in their fields. For instance, your parents have informed you that in the next semester you will stop for the meantime as they are financially incapable to send you to college. It is just one semester more, just the practice teaching that you need to fulfill to finish your degree. The problem is, how would you financially support your last semester in school? This dilemma is the current state of the situation. Number 2. Step 2. Define goals. The second aspect of the model requires you to carefully define your goals in the problem situation. This is different from identifying the problem. For a problem situation, a group of people could identify the existence of a general problem and agree that it represents an opportunity, but still disagree about what their goals should be. Different goals often reflect differences in how people understand a problem. For the problem situation above, the goal is to continue with your college education because it is just one semester before graduation. Another student with the same problematic situation may have a different goal. Different goals can lead people to explore very different strategies for solving a problem. Step 3. Explore possible strategies. This step involves looking at your goals and finding possible strategies to solve the problem. It entails the recall of procedural knowledge from long-term memory. As you think of alternative way to solve the problem, ascertain that the chosen alternative fits the goal set. Bransford and Stein argued that even when people explicitly try to solve the problems, they often fail to use appropriate strategies. Some strategies in problem solving are very general and apply to almost any problem, whereas these are strategies that are very specific and applicable only to a few limited cases. Many strategies are suggested to make problem solving easier. However, the two main strategies used are heuristic and algorithm. Heuristic is a rule of thumb, a mental shortcut that works for solving a problem, especially those about decision-making tasks. Although there is no 100% certainty that the strategy is successful or adequate to solve the problem, it is most of the time effective and efficient in solving the problem. Because of its efficiency, the heuristic can lessen the time to solve and can reduce cognitive load. A student who is always late to class may use the alarm clock in the cell phone to signal it is time to wake up. It may work effectively at times, but if one's in deep slumber, the person may not be awakened by the alarm. In another example, a mathematics student may know the application of FOIL, the first, outside, inside, and last, and can solve problems involving simple numbers, but it may not be able to answer correctly because he or she does not know the multiplication rules of signed numbers. Besides, Newell and Simon suggested 3 general problem-solving heuristics for moving from a given state to a goal state: random trial and error, hill climbing, and means-ends analysis. Random trial and error involve randomly selecting a legal move and applying it to create a new problem state and repeating that process until the goal state is reached. Random trial and error may work for simple problems but is not efficient for complex ones. Next, hill climbing. Hill climbing involves selecting the legal move that moves the problem solver closer to the goal. Hill climbing will not work for problems in which the problem solver must take a move that temporarily moves away from the goal, as is required in many problems. Next, the means-end analysis. The means-end analysis involves creating goals and seeking moves that can accomplish the goal. If a goal cannot be directly accomplished, a sub-goal is created to remove one or more obstacles. The second major strategy is an algorithm. Algorithm is the use of a series of steps to solve a problem. The elements of an algorithm include clarity of what is to be done, defined inputs, outputs, results, and preconditions. Computer programming is a classic example using an algorithm. The use of if-then propositions tells the preconditions for the next step to progress. If the next step does not satisfy the condition, it will not result in the expected goal. Doing the stunned algorithms for the fundamental operations in mathematics required doing the same steps repeatedly with each place value column in given problem. Step 4. Anticipate outcomes and act. Once a strategy is selected, the person must anticipate what outcomes will likely be. The expectation is the solution to the problem. When assured that the goal will be solved, the person acts or implements the planned strategy. For example, a learner anticipates that the answer is to the problem 23 multiplied by 20 should be more than 400 but not 500. It should be less than 400 because 20 times 20 is already 400. This assurance gives the person the confidence to implement the planned strategy. When a person withdraws money through the ATM, the anticipation is that money will be churned out by the machine. That motivates the person to follow the steps as cued by the machine. Step 5. Look back and learn. What transpired after the planned strategy to solve the problem is proof of its effectiveness. In metacognition, this step is the evaluation of the actions or solutions implemented. If the results give the correct answer, then the strategy used is good and effective. If the answer is wrong, then metacognitively ask what went wrong. The answer could be in the details missed during the analysis of the problem, the inappropriateness of the heuristic or algorithm strategy, or in the miscalculations. Realizing the errors committed along the way will make the person understand the mistakes committed. Learning from the experience will make the person more careful next time a similar task is given. Next is barriers to problem solving. In the search for alternative strategies to solve the problem, the individual finds difficulty in coming up with a potential solution because of varied reasons. Under listed some of these and they are as follows. Number 1, mental set. The situation when the person becomes fixated on the use of strategy that previously produced the right solution, but in the new situation, it is not the application. In metacognitive thinking, this is conditional knowledge. An English language learner may be fixated on the rule that the past tense of the verb is usually formed by adding ed to the base form. Thus, given an irregular verb like go, the answer could be good. Moreover, a mathematics learner could not get the sum of 3-digit numbers that require carrying over because he or she is fixated to the addition of numbers without carrying over. Number 2, functional fixedness. This is a phenomenon when individuals fail to recognize that objects can have other purposes aside from the traditional use they were made for. A learner may think that a spoon is only used for eating. However, in instances when no bottle opener is available, a spoon usually used to open a bottle of soda drink. Number 3, failure to distinguish an irrelevant information. This happens when a situation arises during analysis of a problem when an individual cannot discern the relevant information needed in planning the strategy to solve a problem. When the irrelevant information is given more emphasis in the process, it will lead to a wrong solution to the problem. An example is a problem of what to include in a bulletin announcement to help someone who lost a bunch of cookies. Children were asked which details to include were relevant, like where and when it was lost, how many keys are there in the key holder, which keys are these, who owned it, where the key holder was bought, when it was bought. Some children may not be able to identify the relevant from the irrelevant ones. Next, creativity and problem solving. As pointed out in the earlier discussion, mental set and functional fixedness are stumbling blocks in problem solving. These obstacles hamper the consideration of new alternative ways to solve a problem. They illustrate the lack of creativity on the part of the person. Theorists agree that creative problem solving must be taught and encouraged among learners.
What is creativity? Plucker defined creativity as the interaction among aptitude, process, and the environment by which an individual or group produces a perceptible product that is both novel and useful as defined within a social context. The definition underscores the role of aptitude, process, product, novelty, and use. According to Plucker, aptitude represents a dynamic set of characteristics. This includes openness, tolerance for ambiguity, flexibility in thinking, perseverance, motivation for creativity, and need for self expression, as well as abilities pertaining to the creative process that can be shaped by experience, learning, and training. Varied theories explain how creativity is developed. One is the developmental theory, which advocates that creativity develops over time from potential to achievement, mediated by an interaction of a person and environment. It emphasizes the influence of the place, family structures, the role of play, and support during transitions. Meanwhile, the cognitive theory of creativity states that ideational thought processes a foundational to creative persons and accomplishment. Individuals who discern remote association are good at divergent or convergent thinking and conceptual combination and metacognitive process like to be more creative. Next, the stage and componential process of creativity point out that creativity expression proceeds through a series of stages or components. The process can have linear and recursive elements. It highlights the importance of preparation, incubation and insight, and verification and evaluation in creative thinking. One of the first models of creativity was advanced by Guilford. He considered creative a divergent thinking act. He claimed that creativity is the result of several processes: fluency, flexibility, originality, and elaboration. First, fluency. Fluency is defined as the ability to produce a great number of ideas or problem solutions in a short period. In solving problems related to solid waste, a learner can give novel ideas on recycling a plastic water container more than the other learners, which demonstrates fluency. Next, flexibility. Flexibility is the ability to simultaneously propose a variety of approaches to a specific problem. In recycling a plastic water container, a learner can suggest many ways of using them. It can be used as container, wall decoration, and insect trap, which shows that the learner has flexibility of ideas. Meanwhile, originality refers to the ability to produce new, original ideas as well as products. If there is no other learner who gave the same idea or product of another learner, that idea is original as there is only one learner who could think of it. Lastly, elaboration. Elaboration is the ability to systematize, and organize the details of an idea in one's head and carry out. If the learner could pick one solution to solve a problem and give specific details to implement the same, he or she is manifesting elaborations. The creative process follows certain stages according to Bowden, Gabora, and Sanders Smith. This includes preparation, incubation, elimination, and verification. Preparation is the initial stage of the creative process. It involves becoming passionate about an idea, which motivates you to gather materials, read, observe, and compare. The information gathered seeps into your subconsciousness, eventually remaining there momentarily. The next step is incubation. This is the period where the person unconsciously continues to work on the idea, but there is no active attempt to solve the problem. The mind just wanders until an idea takes form. In the next step, illumination, a sudden idea pops out in the mind of the person. The subconscious thoughts find the connection with the consciousness, resulting in the AHA and Eureka moments. Once the idea is concretized, it needs to be verified. Last step is verification. Verification is the final stage of the creative process. It involves working with the idea into a form that can be tested and once proven, it could be communicated to others. Next, transfer of learning in problem solving and creativity. Problem solving is made easier if the learner can retrieve declarative knowledge, procedural knowledge, and conditional knowledge from the long-term memory. If the problem-solving task requires convergent answers, problem solving can be quite easy if the learner has mastered algorithm techniques. Nevertheless, even if the problem solving tasks require divergent thinking, if there have been experiences in the past that enable the learner answer such tasks, solving them could be successfully done. The phenomenon that past experiences in solving problems are carried over or used in the solving new problems is referred to as the transfer of learning. The types of transfer learning are categorized into the following. Number 1. Near transfer and far transfer. When learners apply their knowledge and skills in situations and contexts that are very close to those in which the learning occurred, it is near transfer. When learners perform a skill in a context very much different from the context it was learned, it is far transfer, according to Johnson. Learners find it easier to add three-digit numbers after they have learned the lesson. It is near transfer. However, they find difficulty employing the same skill when the task is transformed into a word problem solving. Far transfer. Number 2. Positive and negative transfer. When learners can use their prior knowledge or experience in solving a new problem situation, it is a positive transfer. When the previous learning or skill obstructs the acquisition of a new skill or the solving of a problem, it is negative transfer. Using a new model of the same brand of Android mobile phone is easy as the features are most likely the same. It is positive transfer. However, when a new phone using iOS technology is bought, there will be difficulty in using it in the first time. It is negative transfer. Number 3. Vertical transfer and lateral transfer. When the learners use their learning at a lower level to perform a higher level of cognitive tasks, vertical transfer occurs. It is the goal of the spiral progression in the K-12 curriculum. When learners use the same skill to solve a related but different problem of the comparable level of difficulty after learning it, lateral transfer happens. For example, Ruben finds it easy to add 5-digit numbers as he has mastered adding numbers with or without carrying over in the previous grade. It is vertical transfer. Likewise, Ruben relies on his knowledge of finding ratios in mathematics in acquiring the skill of finding the seed of germination rate in science laboratory tasks, that is lateral transfer. Number 4, neutral or zero transfer. This happens when past learning or prior knowledge does not enhance or hinder the acquisition of new skill or in the solution of a problem. According to Woolfolk, several theories explain how learning is transferred from one situation to another. Number 1. The theory of identical elements by Thorndike maintains that the quality of transfer depends on the identical elements that are common in both past and new situations. If the content, method, goal, and attitude in the two situations are similar, the transfer is facilitated. Number 2. The theory of generalization, developed by Jude. It, is, it states that skills learned are transferable to other situations. It argues that if the learner has fully understood the lesson and mastered the competency, there is a greater likelihood that such skill can be transferred to a similar situation. Meanwhile, the theory of configuration, anchored on Gestalt psychology, it emphasizes the important role of perception in the transfer of learning. It argues that what is learned in one situation can be shifted directly to another situation only when similarity in content, method, or attitude of the two situations is perceived by the learner. Classroom application of cognitive learning theories. Teachers can benefit from the teaching principles associated with cognitive learning theories. Along with the problem solving, Woolfolk recommended the following. Number 1. Ask students if they understand the problem. Let them separate relevant from irrelevant information. Test their awareness of the assumptions. Encourage them to visualize the problem by diagramming or drawing it. Ask them to explain the problem to someone else. Number 2. Encourage attempts to see the problem from different angles. Suggest several different possibilities yourself and then ask students to offer some. Give students practice in taking and defending different points of view on an issue. Number 3. Let students think. Do not just hand them solutions. Offer individual problems as well as group problems so that each student has the chance to practice. Give partial credit if students have good reasons for wrong solutions to problem. If students are stuck, resist the temptation to give too many clues. Let them think about the issue overnight. Number 4. Help students develop systematic ways of considering alternatives. Tell them to think out loud as they solve problems. Ask, what would happen if? Give a list of suggestions. And number 5, teach heuristics. Encourage them to use analogies to solve problems. In teaching creativity, Wolf also recommend the following strategies in teaching learners. Number 1. Accept and encourage divergent thinking. Reinforce attempts at unusual solutions to problems, even if the final product is not perfect. Offer choices in topics for projects or modes of representation, written, oral, visual or graphic, or using technology. Number 2. Tolerate dissent. Ask students to support dissenting opinions. Make sure that non-conforming students receive an equal share of classroom privileges and rewards. Number 3, encourage students to trust their judgment. When students ask questions that you think they can answer, rephrase or clarify the questions and direct them back to the students. Give ungraded assignments from time to time. Number 4, emphasize that everyone is capable of creativity in some form. Avoid describing the feats or great artists or inventors as if they were superhuman accomplishments. Recognize creative efforts in each student's work. Have a separate grade for originality on some assignments. Number 5, provide time, space, and materials to support creative projects. Here are some examples. Collect found materials for collages and creation buttons, stones, shells, paper, fabric, beads, seeds, drawing tools, clay, and try flea markets and friends coordinations. Have mirrors and pictures of drawing faces. Make a well lighted space available where children can work on projects, leave them, and come back to finish them. Follow up memorable occasions like field trips, news events, and holidays with opportunities to draw, write, or make music. Number 6. Be a stimulus creative thinking. Use class brainstorming sessions whenever possible. Model creative problem solving by suggesting unusual solutions for class problems. Encourage students to delay judging a particular suggestion for solving a problem until all the possibilities have been considered. And lastly, capitalize on new technology. Ask the students to use free apps to creative visual maps of ideas and share their ideas with others.